Alright, so let's go ahead and use the logistic equation, the logistic function to help us solve a situation that's modeled, for example, 1. So the number N of T of people in a community who are exposed to a particular advertisement is governed by the logistic equation. So initially, N of 0 is equal to 500, and it is observed that N of 1 is equal to 1,000. Solve for N of T if it is predicted that the limiting number of people in the community who will see the advertisement is 50,000. So what we're going to do is first notice, okay, we're dealing with the logistic equation. So it's going to be of the form d of n, d sub t is equal to cap n times a minus b cap n. Alright, so that we get that from the logistic equation. Well, knowing that we're dealing with the logistic equation, I can also now find the solution to the logistic equation by having n of t is equal to a times n sub 0 divided by b times n sub 0 plus a minus b times n sub 0 times e to the negative a t. Alright, again, this comes from what we boxed up right here, so I'll highlight. Alright, we know that that was the solution by all the math work that we did here, and we know we're dealing with since we're told we have the logistic equation, that's why I went ahead and wrote it dn over dt. Alright, so I'm going to go ahead and just erase that to show you where all of our equations are coming from. Alright, now let's write down some things that we know. Well, if at the beginning, when time has not, when we're just starting, we're told that our initial is that 500 people observed. So that's going to be our n sub 0. So we can go ahead and substitute in for that for our n of t. So n of t is equal to 500a divided by 500b plus a minus b times 500. Let me go ahead and make 500b times e to the negative at. Alright. Now, what we want to do is look at any of the information that we have. We have n of 1 is 1,000. Alright, so that tells us that after, looks like it could be in days. I'm just looking for the time units that they gave us. Alright, so after 1 day or 1 hour, I'm not seeing any time units. So after 1 day or 1 hour, 1,000 people have now seen the advertisement. And so, that's really not going to give us any information to help us solve for, A or B. But we're told that we have a carrying capacity, is that the max number of people that is going to be able to see the advertisement is 50,000. So, if we have a carrying capacity, we can go back to that kind of limit definition. As time increases, as time goes off to infinity, we're going to be reaching our carrying capacity of n of t, which is just going to be a over b. Well, if our max number of people is going to be 50,000, then we can rewrite this equation to be a over b is equal to 50,000. Alright, and so now we're going to use that to help us solve and find our a's and find our b's. Now, one thing I want to tell you, you don't have to do it exactly the way that I am doing it right now. I just found that this to be probably the fastest method, because you can actually solve and see everything go out. But if you wanted to, you could say A is equal to 50,000 B, and then you could plug into n of 1 is equal to 1,000 and substitute wherever there's an A. You can substitute 50,000 B. Solve it that way, that's fine. Alright? What I'm going to do is I'm going to take the equation that's above, and I'm going to divide the top and the bottom by B, so that I have 500 times A over B divided by 500 b divided by b is just 1, plus, and then I'll divide that by b, and so it's going to be a over b minus 500 e to negative at. And then what we said was that a over b is 50,000, so then we can rewrite that as 500 times 50,000 divided by 500 plus 50,000 minus 500 e to the negative at. Alright, once we do that, we realize, okay, I can pull out a 500 from the top. So if we pull out a 500 from the top, I'm just going to write this as N of t. From the top and bottom, we're going to get 50,000 on top. And then we have 500, so take that out, so it's going to be 1. Taking out 500 from 50,000, so we're going to be left with 100. 2 zeros, yeah. And then minus, take out 500, so 1, e to the negative at. And so now we've simplified our function. Instead of, having it in this format, we simplified it to where now we only have an a and a t, and knowing that n sub 1 is equal to 1,000, we can now substitute in for equation 1 plus 99. Let's go ahead and write that. 99 e to the negative, and then we have at, where our t value is just 1, and that's set equal to 1,000. Now, I'm okay with you now using a graphing calculator to solve this. All right, you can, you can use a graph. You can use Desmos to solve. Okay, what's a going to be? All right, or you can just solve this by hand. All right, you can multiply the 1 plus 99 e to the negative a to the right hand side and get 1,000 plus 99,000 e to the negative a. And then what you can do is then subtract the 1,000 and get 49,000 divided by 99,000, and you would eventually get a is equal to negative natural log of 49 over 99. I'll say 49,000 over 99,000 just so that you can see where our numbers are coming from. That's if you solve for a. I'm only doing this because we don't have much time, and that's algebra 2. And so we could say that a is equal to 7, or 0.703.7033. Again, if you plugged this in to your graphing calculator and made ax, it would spit out what a is. All right. Now that we know what a is, we can plug a into our function right up here. Not function, but into our expression, our equation a over b, where we can say 0.70333 divided by b is equal to 50,000. And we'll be able to solve for b. When we do that, we get b is equal to 0.0000014. Now, this is why I did it. This is why I divided by b. Because if I had tried to do a equals 50,000 b and then plug it into my graphing calculator to solve, it's going to be a very, very small number. It's going to be hard to find using the graphing calculator. So that's why I went and set it this way. All right, so now we have a, now we have b, so now we can substitute this in to actually have our equation that's going to model our, use it in green, situation. So we have n of t is equal to 50,000 over 1 plus 99 e to the negative Where's my A at? 7, 0, 3, 3. That's D, T. Right? Alright, one last thing before we finish this page is modifications to the logistic equation. There are many variations of the logistic equation. For example, the differential equation is dp over dt is equal to p times a minus bp. So there you see the logistic equation part, but then you have a minus h or you have a plus h. That minus h or plus h is when we're either adding to the population or subtracting by the population. So here you see this is an example. So these could serve as models for the population of fishery where fish are harvested, minus h, or restocked, plus h, at rate h. The equations could also serve as models of the human population decreased by immigration or increased by immigration, respectively. The rate h could be a function of time, t, or could be population dependent. All right, so we'll work on example 2.